Now we have a question here that says find the range of values of x for which 3 minus 2x greater than 5 or 2x minus 1 greater than or equal to 5 are both satisfied. Show the range of values in a graph. Now I don't think this is going to be really challenging just because of the ambiguities here. What it simply means is that we are going to solve these two equations separately but together. Now what do I mean? So on the one hand, I'm going to write down 3 minus 2x greater than 5 or 2x minus 1 greater than or equal to 5. Now when I simplify them and get the values of x, I'm simply going to show it in a graph, and I'm going to show those regions in the graph where it satisfies both inequalities. Now the first one here, all we need to do is we are going to transfer 3 over to the other side, and this becomes negative 2x greater than 5 minus 3. So we have minus 2x greater than 2. Now if we divide both sides by negative 2, remember, once you divide both sides by a negative sign, the inequality changes to the opposite. So this here becomes x less than negative 1, all right? So we have that. Now go over to the other one. Here you have 2x greater than or equal to 5 plus 1, because 1 goes over, minus 1 goes over. Now that becomes 2x greater than or equal to 6. If you divide both sides by 2, you have x equals 3. So how would you show those range of values that this is x greater than or equal to 3. So how would you show those range of values that satisfies these inequalities? Now I'm just going to draw a line, a number line. Okay, the middle is 0. To the left side you have the negative values, to the right you have the positive values. Now you can see here we have a negative 1, right? So here we have negative 1, negative 2, negative 3, and so forth. And over here we have positive 1, 2, 3, 4, and so forth. You can stop wherever you want to stop, it doesn't matter. So now we are going to show the arrows. So what we are doing basically on the number line is showing you the range of values where these two equations are satisfied. So for the first one, it says that x is less than negative 1. Now remember that negative 2 is less than negative 1, and negative 3 is less than negative 2 less than negative 1. So that means since it says less than, so we're going to start from here, and we have our open circle because it's just less than, then our arrow goes this way. So these are all the numbers that are less than negative 1. And now for this one, where do we start from? We start from our 3, and it says that x is greater or equal to 3. So we're going to have our closed circle because it says equal to, and then it goes this way to indicate all the numbers that are greater than 3, 4, 5, 6, and so forth. So we've shown our range of values for this question. Now let's take another question. Find the range of values of x for which 1 over 2x plus 1 greater than 3 and x greater than 2x minus 6 are satisfied. So here I'm going to show you how you write down the range of values and how you also go ahead to represent it on a graph, even though we were not asked to show it on a graph. So it's the same format as we just solved in the previous question. So I'm going to write out this one, 1 over 2x plus 1 greater than or greater than 3, and x greater than 2x minus 6. So let's work this out. Now over here, this is half. So I will simply multiply through by 2 so that I'm not going to have any half here. So if I do that, I'll be having, if I multiply through here by 2, that's going to be x plus 2 greater than 6. And then if plus 2 goes over, it becomes x greater than 6 minus 2, so x is greater than 4. Okay, so the next one, over here, 2x is going to come over to become x minus 2x greater than negative 6. And so this becomes minus x greater than negative 6, which if we divide both sides by negative 1, so we're going to be having x less than 6. Remember, the sign must change because you divided both sides by negative. So now how do we write out the range of values now? And they want us to combine these two. Now you can take note from here that x is greater than 4. But here x is less than 6. So that makes it easy, which means that x started right after 4 and it ended right before 6. So it means that x is, so if x is greater than 4, it means that 4 is less than x, and x in turn is less than 6. So this is how you write range of values when you're combining it in two questions like this, two inequalities like this. So in this case, x, as you can see, is greater than 4. So that's why I have it as 4 is less than x, and x here is less than 6, and that's why we have x less than 6. Now, how would you represent this on a number line? Very easy. So you can see these two numbers are on the positive side, right? So let's say we have our 0 here, then every other thing towards the left-hand side is negative. So here we have 1, 2, 3, 4, 5, 6, right? So since they are connected, all right, it means this is going to start from 4 and it's going to end at 6. It's going to start from 4 and end at 6. Now, in both cases, it is only less than, but no equal to. So that means both circles at the points of 4 and 6 are going to be open. That's how we represent it on a number line. So x starts from 4 and goes to 6, but it doesn't start from 4. It starts right after 4 and gets right before 6. So logically, x is between all the values between 4 and 6, but never touches 4 or 6. So let me give you something to do.